Here's your function notation ditto, and I just wanted to do a few of them just to jog your memory here and see if I could do some of the tougher ones and see if you could finish the rest. So let's take a look at problem number one here and look at the two different types of questions that you're asked with function notation. You'll notice these first two, A and B here, have a number that's inside the parentheses. See that number there? As opposed to the next two here where it's not inside those parentheses. That number inside the parentheses is literally replacing x. 16 replaces that x value right there. And what that tells you is let the x values be 16. So when you go to the equation part, the expression over here, you're going to put 16 for all of the x's, whether it has one x or it might have multiple x's. This is telling you to plug 16 in for x. And then you're just going to find out what that equation ends up being numerically. So when I put 16 into the F equation, you'll notice this one's called G and this one's called H. I put 16 here. Conveniently, 16 minus 7 is 9, and the square root of 9 is very friendly. It is just 3. Okay, so 3 is our answer to that guy. And if you are plugging in a value for x, like on B here, it's important to remember, especially when you're dealing with negatives, when you substitute a value for anything, you should use parentheses because the rules of the other parts of the expression apply to it. So this -5, when you put it here, it takes on a huge difference if you leave off the parentheses. Okay, the way I've written it right now, only the 5 would be squared, which is bad. We are supposed to put -5 in here for x, and x has to be squared, which means this entire thing needs to be squared, and that's why the parentheses here are crucial. They're also crucial in the next one because we have to distribute or multiply by this -5 that's here. So whenever you substitute for x, use parentheses. Okay, this first one here, when I put that 16, I didn't use parentheses. Maybe a little bit lazy, but my mind knew, you know what, there's nothing next to that x. There's nothing in front of it. There's not an exponent. So the parentheses didn't change the value or the answer to that one there. But here, the parentheses are crucial in both places. -5 squared is -5 times -5, which we all know is positive 25. Here is -5 times -5, which is positive 25. And we get 50 as our answer. So get used to those two notations. This is plugging in x values because those two numbers are located where there typically is an x value. The next two is the different type of question, the second form of this. And you'll notice it's got this weird extra set of directions in the front here because you'll go back to the original problem and it says find, usually it's ... or a colon here, find x when h of x equals 6. And I'll tell you right now, the biggest error, the most common error is somebody's going to take this 6 and put it in for x. That's what they do. That's the boo-boo that takes place. When the question says find x, your biggest hint is you don't know what x is. So for somebody who makes that mistake to put 6 in for x, that means you know that x is 6, which is contradictory to the entire question. When it says find x, you don't know what it is. So if you can get used to this notation where it says find x when h of x equals 6, hopefully that'll trigger. That doesn't mean you know that x is 6. We don't know that. Now, this problem, because it's function notation, takes on a little bit of harder something that you already knew how to do from integrated 1. And what I mean by that is in integrated 1, you had a system of equations. Take a look at these equations that I'm just making up right here on the spot. Okay, so here's a system of equation. Here's two lines, and in integrated 1, you found out where they intersected. Okay, so you were taught the substitution method. And a lot of you went, you know what, if that guy, 2x minus 3 is equal to y and x plus 1 is equal to y, since they're both equal to y, then you just set them equal to each other. And a lot of you, that's what your brains were telling you, and that's totally fine. It's actually substitution. We're taking this guy right here, and we're putting it in for this y. Since it's equal to y, it's going to replace this y. So it replaces this y, and we put that in its place, and that was substitution. Well, this problem is the same idea. H of x equals 6. H of x equals x squared minus 5x. Since both of these things equal h of x, then they must equal each other. And that's how you solve the problem, just like you did in integrated 1. Okay, so if you can just recognize that this is solving for x, this is a form of substitution, and you're going to get an equation here that you should recognize. We've got a quadratic, so we want this to be equal to 0, so we can use the zero product property. So I'm going to subtract 6 from both sides, moving the 6 over here, and now this thing is ready to be factored, and we find answers. And I say answers, we're going to get more than one. Factoring, I know for some of you is going to require a generic rectangle, totally fine. And then after I factor it, I find the solutions to when those equal 0. 6 makes that guy 0, -1 makes that guy 0, and this problem has 2 answers. And a lot of times when it has 2 answers, I'll take this problem here, and you might have seen it yesterday, find all. And I'll put the word all there just as a reminder, you know what, there's more than one here, and this is just me trying to give you a hint. It's not just one answer. I've had people who just do this problem in their head, and they try to guess one answer. So the all is just kind of a hint that I don't always put. Obviously, it's not here, okay? But that's what the word all is for. Okay, D is going to be a little more challenging because it comes from this fraction here, equation G. Remember, this is G of x equals 2, so we're going to set this equation equal to 2. And we've got a couple of options. We've got an equation that has a fraction. We could do fraction busters. I know a lot of people like fraction busters. There's some of you that hate it. The other option here is, and I'll just show you this one. I don't know if this one's popular or not. First of all, fraction busters, I would multiply this term, and this term by the common denominator, and the common denominator there is the x minus 4. So multiply that by x minus 4, that by x minus 4, and that by x minus 4. Totally fine. I can move the 3 over to this side. So if I subtracted 3 from both sides, that 2 would turn into -1. And what that creates is a fraction equal a fraction. Okay, this is a proportion. Okay, and this may not look like a fraction. If I asked you to make it a fraction, you would all put it on top of 1, right? That's how we turn an integer there into a fraction. And this you could solve with cross multiplying or butterfly or moth or whatever you were taught. So cross multiplying that is an option there. -1 times x minus 4 would be -x plus 4, and 1 times 1 is equal to 1. Okay, so not fraction busters. That's just using a proportion. And we get to an equation here. I'll move the x to the right side, subtract 1, x equals 3 is the answer to that guy. That one's tough. Okay, that one has totally different skills than the others. That's why I wanted to show it to you. I don't think anything new happens in here in problem number 2, so be prepared to give me the answers to those tomorrow. But I did want to jump down here to number 5, just because I thought number 5 down below was tricky. You'll notice I've divided these into sections. So these 3 problems are, I'm giving you the x value. That means you're going to plug it into the equation and give you the answer. And then the next 3, the function is equal to a number, so you're going to set the function equal to it. That's like a substitution, and you're going to solve it. But 5 down here, 4.5 plugged into this equation, J equation, a little tough. 4.5 minus 4 plus 2. And notice I'm staying away from a calculator here. 4.5 minus 4 is 0.5. Now, 1 divided by 0.5, if you don't have a calculator, is tricky for some of you. And I think you were probably taught that in 5th grade. In fact, let me jog some of your memories here. 0.5 is the same as a half. Okay, so if I took this 0.5 and I changed it to a half, it looks like that, which might not make you feel good. This is 1 divided by a half. And in 5th grade, probably, you were taught 1 divided by a half, except it was probably written horizontally. And you were taught when you're doing division of fractions that you can switch this to multiplication and take the reciprocal of that second number there, which would just be 2. So 1 divided by a half is the same as 1 times 2, which is just 2. So this whole cruddy thing right here turns into a 2. 2 plus 2 is equal to 4. So I just wanted to do that one just to show you. And hopefully you can do the rest. Have a good day.